Apache Flex. It was donated by Adobe in 2011 to the Apache organization. It took nearly a year to go from incubation, which is where you get a couple of mentors that help people who are working on the project get up to speed with the way that Apache works and the way that the project is supposed to be working. Then after the incubation, you sort of graduate and become a top-level project, where the project management committee is actually on its own, as it were. So you get to make all the decisions yourself, and the Apache infrastructure, the Apache higher management is basically there for you if you need it, but they won't interfere. Well, as you've probably heard before, it's one of the more active projects within the Apache organization, so we're really proud of that. For myself, I've been a contributor from 2012. Then after a while, you become a committer if you've contributed enough, or at least you've been busy on the project enough, and then eventually you can become a project, you can be invited to become a project manager as well. There's a lot of projects, or some projects actually, within Apache Flex. So I'm going to be talking about a few of them, and then also a bit about the infrastructure that surrounds those projects and make developing on them as less a hassle as it could be. So we'll talk about the installer, which you're probably all familiar with. The installer badge, my baby, so I'll show you that. The SDK itself, but I'm not going to be talking a lot about that today. Then Mustella and continuous integration, so supporting projects. And then at the end, I'm going to talk to you a bit about the new compiler and what we're doing with that. So FalconJx. Alex talked about that a bit yesterday. Vanilla SDK, so sidetrack project I started. And then finally FlexJS. Talk to you a bit about the background behind those projects. For the installer, the SDK itself is actually rather difficult to set up, even for application developers. So the plain code or binaries is a bit of a hassle. So what Arm did was take the bundle of scripts that it needs to run in a particular sequence and sort of automate that for you and build a nice UI around it. So it's actually sort of a tool to get the tool working. Easy developer access is, I think, and I think most people agree, crucial for the project. I mean, we can build nice things, but if nobody's able to get those features on their machine so they can build better applications, then the project will probably fade away pretty quickly. So the installer, as I said, automates all steps in the setup process. Basically, click and go, point to a directory. Since it was one of the first sub-projects that we made an official Apache release for, it was quite an involved process. And I'm proud to say that the 10 release candidates still hold the record for the most release candidates that were needed. There have been 3 versions so far, where version 1.0 was basically just setting up the SDK on the user's machine. Version 2.0 was more user experience. The interface improved, and there was localization added, so that makes the international deployment of the SDK much more accessible. And then, quite recently, version 3.0 was released, where there's a feature was added that's called end-to-air, something that Alex built, which basically means that from now on, the installer itself doesn't take care of the preparation of the SDK, but the build scripts that you would actually use if you do it manually are read by the installer and then executed. So that makes it much easier for us to update the way the SDK, for instance, is installed without actually also having to do a parallel update to the installer. So that takes away a bit of the effort from each official release for Apache Flex. There needs to be a voting process, which is quite involved and sometimes takes more than a couple of release candidates before it's approved and it becomes an official release. So the fewer releases we need to do, the better it is for the project because we keep time to do more interesting stuff. So the installer badge was my first contribution to Apache Flex. It's a custom AIR application installer badge. So it will get add that in a web page and then it will install the installer. I built it such that it uses an iframe. If you embed it in the HTML, the iframe loads the badge into the web page that's embedding the iframe. That makes it easy for other people to use the exact same badge as the Apache site uses. And that way you can easily update either the installer badge or the versions, for instance. It has two size formats, one of them isn't used. And I'll show you really quickly how it works. What it does is it dynamically reads the installer version that's currently the latest, and then if you click on the download button, it simply downloads the installer to your machine. But since it's centrally kept and embedded remotely, you can also have other websites, like for instance this Spanish site, where you see should be able to see the exact same thing. Every time we do a release, we update the configuration file for the installer itself. And the badge reads that, so you see that there is currently a 4.12.1. It's the most current release. The idea is that if, for instance, bloggers or other websites embed it's in their web page, their viewers will always see the latest version of which is the latest version of the SDK, and they'll have a handy tool for them to download the installer. Okay. Not the SDK went away, but Justin will take care of that in the next session, so that's as well. Next up is Mustella. Mustella is the test suite, the functional test suite for the Apache Flex SDK. It's quite comprehensive. It came with the SDK when Adobe donated it. There are about 40,000 tests in Mustella that test basically every aspect of the SDK. So running that regularly is very important because it ensures that if the change has been made to the SDK, if the bug has been fixed in the SDK, it will be tested against all possible features. Because sometimes when you change something in one place, something in a different place breaks, and you'll never be able to tell upfront whether or not that will happen. So what we do is we run Mustella basically before we commit any changes to the SDK. But Mustella is very difficult to run locally. It takes a lot of resources. So what you end up with, because the complete run from Mustella takes anywhere from 8 to 12 hours, depending on your CPUs and etc. And when it runs, particularly on Macs, it just takes away the entire machine. So you can run it in the background and wait until it's finished. So what we did is to have a consistent way of testing the SDK whenever a new commit is made. We build a virtual machine on Microsoft Azure's cloud services, which comes free with the MSDN subscription that Apache committers get. It uses the Jenkins continuous integration tool, which I'll talk about a bit more later on. And since it runs on the virtual machine that nobody else uses, so in production it can sort of run continuously, which means that at least twice daily the entire suite for the SDK, mobile, and air is running. And it means that also whenever something breaks, automated notifications is sent out to the devs that committed those changes, as well as the development emailing list, so everybody knows that something happened in the last day, and it'll give details as well. Something happened in the last day that broke the SDK. Let me show you a bit about how that looks. Okay, so you get a dashboard with Jenkins where you can just use your browser and remotely access the services. As you can see, there's 4 jobs in this running on this machine at any one time. TLF, the text layer framework, which is basically only there that if somebody makes a change to that, the most recent version is available for the SDK tests. And then there are 3 test suites. The biggest one is for the SDK itself. And that, as you can see, takes about 9.5 hours to run on this machine. Then there's the air tests, which test particular air player features, and the mobile tests that, as the name suggests, do the same for the mobile components. So the whole suite, as you can see, takes about 12 hours to run. The last duration was 9.5 for the SDK, about 30 minutes for the air tests, and well, like 2 minutes 44 seconds, but that failed. As you can see currently, as soon as the blue dot turns red, something's up. So currently, both the mobile suite and the SDK suite itself aren't correctly running. I checked the mobile and I just had problems downloading some dependencies. But the SDK was broken too. So I figured that Mike, who committed yesterday, one of his things broke. One of it was proudly proclaiming that Mustella passed for him. But not on the Windows machine this is running on. So that's how we sort of do quality assurance for the SDK. We don't go in and test features in real life applications. We have Mustella who does that for us. One thing is that for most newer components, Mustella doesn't have tests. Sort of kind of gotten a bit out of hand. We don't require you to write tests for any components. We're glad that somebody contributes new components. But for now, what we do is we put those components in the experimental namespace in the SDK, so that ensures that whenever a problem arises with those, it's experimental, so we can say, look, we're responsible for it. If at any point somebody jumps in and writes proper unit tests and functional tests for those components, we certainly would consider putting those in the main SDK, main namespace. Okay, continuous integration. Well, our quality assurance thing is that whenever somebody commits, we just check whether or not the SDK builds. So we don't necessarily run all the tests immediately, that happens on the other virtual machine, but we do check whether or not the build scripts run and whether the SDK is able to be sort of the binaries properly are assembled. We used to run those on Apache provided machines. Apache has this whole infrastructure that helps the projects with, for instance, services like the continuous integration. They also use Jenkins, or rather we use Jenkins because they did. But since there's a lot of Apache projects, we don't necessarily get the attention that we would like if something's wrong with those builds. And a lot of things go wrong with the Jenkins jobs, mainly because a lot of other projects also have dependencies. Those machines, those virtual machines that run on, are sort of your worst nightmare when it comes to dependencies and conflicts that come up between those. So there has been a lot of downtime on the Apache build machines, and just a month ago we decided, well, we've got this one virtual machine that runs Mustella, which is really successful. So now we have another virtual machine that we might be able to use instead of the Apache. Servers, and actually Alex donated his SDN provided Windows Azure virtual machine. That's been running now for I think about a month, a couple of weeks a month. It's been very stable because there's no other jobs that get in the way, there's no dependencies that sort of collide. So I'm sure what's on that machine as well. As I said, there's a lot of projects that go all fall on the Apache Flex server. So with the ASJS, which is an important component for FlexJS, recently released BaseJS, then we have Falcon, which is something that is built in the compiler that Adobe donated. FlexJS, which was also recently donated, runs the SDK itself and the release version. Building the SDK is one thing, but then for the release you need to do a whole bunch of other steps. So we run both of them. The SDK is sort of the early warning system, and the SDK release job is to make sure that every step of building the release version of the SDK is still functional. As I said, text and layout framework, although there's some work going on that, it's mostly static, but it's there so the other jobs can use its output and then install it. So most of them are running fine. I'm sure FlexJS sort of works on its dependencies, and the release probably had trouble downloading one of the dependencies as well. But as you can see, the times these jobs take are a lot less than Mustella. So what we do is we've set up the machine such that whenever there's been a commit, it immediately runs the jobs and check that commit against the building of the SDK. And if no commits have been done, then still on a daily basis we run them anyway just to see whether the bin shifted or something like that. Okay, on to Falcon. I mean, if there's any questions, please feel free to interrupt. I know I'm going a bit fast, but a lot of things that I want to go over. Falcon is actually the branch of the Adobe ASC 2.0 compiler that was donated from Adobe to Apache Flex and sort of abandoned. We got some support from Gordon Smith, but he went away to other projects. So basically, for now, there's not a lot of development going into the actual compiler, but at some point, we want to use it to replace the current compiler. There's some discussion whether or not that makes sense. The new compiler turns out in its current state not to be really that much faster than the current one. And since it's not yet feature complete, there's a bunch of XML that it doesn't parse correctly or at all. So we're not sure. That's basically on hold, but it is sort of the base layer in the whole new FlexJS stack. So I'm not to that in a minute. But what basically the compiler does, it takes ActionScript and XML. It parses that into an abstract syntax tree. This is basically a representation of the relations within the code. And then what it does is translate that, or uses that abstract syntax tree to build the bytecode that's then wrapped in the Swift. So that's what it does for if you do the regular SDK to Swift application. But what we are currently using it for is together with FalconJx. FalconJx, it takes, it's a cross compiler. So what it does, it takes ActionScript and produces JavaScript. So it uses Falcon to convert the ActionScript and XML to, let's say, an abstract syntax tree. But then instead of writing out Python code, it writes out JavaScript. FalconJx was started by Mustella. He set it up, was a really clever guy. I sort of picked it up once the whole the structure was in place. So all that was left for me was to go in there, write unit tests for particular features of ActionScript, and then write out what the JavaScript would be for that particular piece of ActionScript. The languages are seemingly similar, but not all that much. So there was a challenge there, and also Mike never got around to writing the support for MXML. So what I basically had to do was add another compile step that would parse the MXML and take all the words from that, and then put that into JavaScript as well. But by that time, I was already invented sort of a data structure, which the JavaScript side uses to represent MXML, so it was also really straightforward. The only challenge that's still left in FalconJx is that if you have ActionScript embedded in the MXML, then it gets really interesting because it goes from one to the other and then back again. So that's why we're using, or hoping, at least with the FlexJS releases, that people will start using it and we'll get to the use cases that we didn't think of ourselves. Also, the way it's set up is that since you take the abstract syntax tree and then you write your own parser for that, there's many types of JavaScript output possible based on that one syntax tree that the compiler uses. So at some point we had, I think, the support for FalconJx as a way of doing the JavaScript output. I wasn't familiar with that, so I sort of ignored that and started fresh with the Google Closure output, which is what I'm familiar with. It's a way of writing JavaScript that's very familiar to ActionScript people. So we decided to go with that. But, well, since the FalconJx is open source as well, what you could do conceivably is go in there and write output for whatever framework you want the ActionScript to be represented. So it's very flexible that way. It isn't as hard as it looks to actually get another JavaScript output type working. The one I started work on was what I at that time called the Vanilla SDK. As I said, JavaScript and ActionScript are very similar, but they're not the same. JavaScript doesn't have of itself a notion of interfaces, for instance, the way ActionScript does. So what you get is if you ask whether or not one object is an instance of an interface or is an interface, you need to prepare the JavaScript, as it were, to have knowledge of what interfaces are used in the original ActionScript. So that's where the sort of tricky part comes in, to sort of define in JavaScript new features, as it were, that match the ones on the ActionScript side. There's not a lot of them, but there are. There's a wiki page that lists them, and the solution we decided upon to use on the JavaScript side. Vanilla SDK, as compared to FlexJS, was based on the idea that we have a perfectly good SDK on the ActionScript side, the Flex SDK itself, and we just needed a sort of complementary SDK on the JavaScript side. Turns out it wasn't that easy, but I figured at that point that we might as well use what we've got and don't put a lot of effort in the ActionScript side. But that got sidetracked because FlexJS sort of took priority and most interested in what Alex explained yesterday, light components, light output, and the ability to create a modern framework instead of building further on the Flex SDK itself. My choice, as I said, was the Google Closure tools to help with matching the JavaScript side to the ActionScript side. So what we have is the Google library that we use as sort of the foundation for the SDK, the JavaScript SDK. As I said, you have to matching objects on the JavaScript side. So if, for instance, you want to raise an event, then the event object must be available on the JavaScript side as it is available on the ActionScript side. So you can match up the features for the ActionScript SDK on the JavaScript SDK side. And then the most important tool is the Closure compiler, which is a true compiler for JavaScript. So it takes JavaScript, takes it apart, and then puts it back together again with optimized. So it removes the get code, changes the functions around, for instance, for inlining. So that makes the JavaScript that it outputs much more efficient, and also, as it is a minifier as well, it takes it down from a couple of hundred K to what Alex showed yesterday, dozens of Ks, 65. I think it's about as low as you can go. It does take a couple of classes as a sort of the foundation which you build. As I said, the Flex SDK to custom JavaScript SDK. Why I stopped, besides that I wanted to really make FlexJS work, is also that it ended up needing on the Flex side a way to prevent developers from using properties that weren't available on the JavaScript side. So for instance, if you use, I don't know, one of the accessibility properties or even properties that would still be worked on, then that would have, it would be translated into JavaScript, but since it wasn't supported on the JavaScript SDK side, it wouldn't do anything. So my idea was to change the Flex SDK, give it namespace, and then sort of inherit the existing objects, and put a sort of a wrapper around it where I can say, okay, this property has not yet been supported by the JavaScript side for the vanilla SDK, so don't use it. Or actually through a runtime error. That's where I sort of left it to help Alex out and the other people contributing to FlexJX by preparing FalconJx to be able to handle the FlexJS output. As Alex explained, we'll go over this even more quickly than I am already. It's to create an optimized and new ActionScript library and the complementary JavaScript library. So it's two new SDKs, as it were, that are being created, which might sound like a lot of work, but since it's set up from the start to work with both the ActionScript and the JavaScript, it's actually, now that the base has been created, it's easy to work on new components. As I mentioned briefly, it uses a very efficient data structure for XML, so it's not actually creating any objects, but what it does, it creates those objects on the fly. So they're not written out as classes, they're written out as a big array of properties and other information, which makes the JavaScript that much more efficient and more forward. As I said, the cross-compiler needs to learn about XML, because the important part for FlexJS is that you can write and play that XML and have that output to JavaScript, and the embedded ActionScript within the XML. You need to publish efficient code. You need to publish the code such that you can also keep up the JavaScript code. The Closure compiler sounds very optimized and very efficient JavaScript, but it minifies it as well, so it's unreadable. And what we did is we added sort of a debug version, especially in the early days for the framework. There's got to be bugs in the way that the ExoScript is translated to the JavaScript, so you need a way to debug that, but also have the release version, so we can keep checking whether or not it was as efficient as we hoped it would be. Libraries are being created right now. So that brings me to, in my opinion, the most important part is we need contributors. We need people to help us with building those SDKs, or even fixing the existing SDK, or any one of the projects that I touched upon. Joining us is really easy. Subscribe to the developers list, see what's going on there. It's a lot of emails per day, especially if we're fighting about something. But it's worth it. You get a feel for how the project works, you get a feel for what's going on, and maybe even get an idea about, oh, I'd like to help with that, or why aren't they doing it this way? I've worked with that before quite a bit, etc. So other resources are the FlexJS site, where there's a little get involved page that will help you understand the steps that are required. And the wiki itself has some information for that as well. If you start out, it's really scary. There's a lot of steps you need to do to even get the SDK to build on your machine, let alone work with it. Just to show that that's not as difficult as it may sound, but it's really daunting. If you go into the README, there's like 9 or 10 dependencies you have to set up. But that's steps you have to set in one time. The dev is more than willing to help you out if you have any troubles. We have had a lot of troubles ourselves, so we basically see all of that. And I mean, one way you can contribute to the project is just write down your experiences in an email or ask for write access to the wiki. Because we know the threshold for entry is still quite high, but we're working as much as we can to make it more accessible. And if you have experiences, please, if you write them down, you will help out sort of the next generation of the people contributing. And it's fun. I think it is. It's really nerdy fun, but it is fun to work on it. And it's really satisfying. And if you have a problem with the SDK, or if you would like to contribute to the next version of the SDK or FlexJS, it's fun to see your own contribution make it into the SDK. So. That was basically what I thought I might have time for. Is there any questions?
So how many contributors are there right now? Like how many people are?
How many contributors? I think very active contributors, 5 or 6 maybe. In total committers, so people who have write access to the repository. I think it's just maybe 30-ish committers like that. People who contributed at one point but now don't have the time or any new ideas to help out. We add people who have been contributing on a regular basis, or have been adding bugs to Jira, or have been solving bugs and submitting patches to Jira. We are watching that. Justin is very much watching that. So if you make some contributions, you're getting noticed, and if you sort of keep it up, then we're more than likely to invite you to become a committer. And even if you, as a committer, you don't necessarily have to contribute any bug fixes to the SDK. If you do documentation work, that's fine as well. If you're very active on the developers list, and you help people out or have suggestions that are really helpful for the development, that's also contributing. So it's not only hardcore going in and fixing runtime errors or something like that, it's also just helping the project along. It's community first, then the code. So that's a threshold. There's not a lot of people, to answer your question, that are on a daily basis very active. So if people take the time to do that, but there's a lot of people sort of working behind the scenes who don't sort of profile themselves very highly on the list, but they are working. For instance, the guy who contributed most of the FlexJS components, Peter Ant, rarely emails to the developers list, but then every couple of weeks we get a big commit, and then the data grid for FlexJS happened, or there's the Cordova stuff that Erik showed that happened. So there's various ways in which you can contribute them, which you are sort of rewarded for, in a sense, that you can provide access as a committer to the database, or even if you do that regularly and your commitment is sort of a study contribution, then eventually certainly be asked to become a project management committee team member. So that's the way Apache works. Any ideas out here? Yeah?
Well, I have some idea, just like the on the power side, that's stuff that understand how to build micro and like that's.
Yeah, I thought so as well. It's as I said, really difficult to get into some of those projects, but from my experience, I've never done Java before I started work on the compiler. With the help of the original guy who worked with FalconJx, he pointed out a few things, and then the sort of ways to get into it. Find a unit test, that was the way I got into it. So you look at the test, put a breakpoint in, then just step through the code. And then, I mean, it didn't happen overnight, but after let's a week or two maybe, of doing that every evening for a bit, and then trying to figure out, okay, what if I put it there? What happens to the output? And since it's JavaScript as output, which is really readable, you can immediately see whether or not what you did makes sense. Then after a week or two, you get the idea, that sort of feeling for the project. And then, well, Java's just another programming language, so Google what you don't know, and pick it up from there.
So that's kind of what we do with all of those flexible. Like, what are each of these 5 people do that you guys are most helpful?
Well, for me, it's mostly the compilers at the moment and the continuous integration. I mean, especially when we were still in that Apache infrastructure, that was sort of a daily job to send an email that something wasn't working. That's about 30 minutes to an hour a day that I spend on the project if I'm not working on a feature. But working on the FalconJx, that's my thing at the moment because I'm really the only one who knows what's in there. Alex knows a lot about it. Since I'm remote, Alex also supports. So if anything comes up that Alex needs or Peter needs in the output, I help out. I'm really familiar with the Google Closure tool, so if there's anything that they need on that side, for instance, the event handling that we built, there's some issues with that we'll work on. Justin is mostly on the SDK. I think fair enough. Alex is on FlexJS, obviously, and does a lot of work and questions, as does Justin on the developers list. We have somebody who's working on the text layout framework and table support to that. That's one of those behind the scenes things, and every once in a while he has a question that pops up and then he sort of surfaces and then it goes down again. So we're waiting on what comes out of that. And then currently there's a couple of people doing a lot of work on nativizing the whole SDK. I don't even pretend to know what that means, but that's what they're working on, and it seems to be really important for the enterprise acceptance. So they're making good progress on that. So it shifts around, because those people who do the nativizing work active for a year maybe until the native nation enabled what they were trying to do. So then they jumped into it. Nativization should be, I think, really coming along nicely. Anyway, that's it for me then. Thank you.